Hey there everybody, Mr. Larson here. So in this video, we're going to be talking about how we can use the crisscross method in order to predict ionic compound formulas. So ionic compounds are, of course, molecules where a metal and a nonmetal bind together through an ionic bond. So they're using their ionic charges, so positive and negative charges, as an attraction force in order to bring them together. So the first example we're going to be talking about is calcium chloride. So in using our handy-dandy ion chart here, we can actually look at what our different charges are. So looking here, calcium has a +2 charge, so we'll jot that down. So calcium here. So calcium is 2+. And chlorine, or chloride, which is chlorine, has a negative charge, so a -1 charge. So calcium here, and then chlorine is here with a -1 charge. So this is calcium, this is chlorine, but now we need to figure out how many, what our actual formula looks like. So basically how many calciums we have and how many chlorines we have in order to make a neutral molecule. How we do that and how we predict that is by using what is called the crisscross method. So it is a very simple tool, a very simple rule that we've used, that chemists use in order to predict these ionic compounds. So it's very simple. All you literally do is crisscross the numbers. So our 2 here gets brought over to the chlorine, and our 1 here gets brought over to the calcium. So when looking at our chemical formula, it would be calcium. We have a single calcium, and we have 2 chlorines using this crisscross method. So this right here, this is our balanced neutral chemical compound, our ionic compound. So we're gonna go through a couple more examples, just kind of walking through the crisscross method again. So let's go to our next example. So our next example is sodium oxide. So when looking at our handy-dandy chart here, sodium is Na with a +1 charge. So we'll go sodium, which is Na plus 1, and oxide. So oxide is just oxygen. And oxygen, or our oxide here, has a charge of -2. So we'll do oxygen with a -2 charge. So once again, we're going to use the crisscross rule in order to figure out how we can bring these 2 molecules together, or 2 elements together, to create a neutral molecule, a neutral ionic compound. So we're going to use a crisscross rule. So this 2 goes to the bottom of Na. This 1 goes to the bottom of oxygen. So we're going to need 2 sodiums and 1 oxygen in order to create a neutral compound. So of course, our -2 comes down to sodium, meaning that we need 2 sodiums, and our +1 with sodium comes down to mean that we only need 1 oxygen. So our final compound here is Na2O. So 2 sodiums and a single oxygen. So let's go through another example. So our next example is magnesium hydroxide. So magnesium, in our list here, magnesium has a charge of 2+. So undo that. So magnesium, that is our Mg, is our chemical, or our element formula, our elemental symbol, and it has a charge of 2+. So now we're trying to bring in hydroxide. So hydroxide is an actual compound. It's one of our polyatomic compounds, or where it has multiple elements in it. And here it tells us hydroxide has the symbol OH and has a -1 charge. So hydroxide, OH. And this entire thing has a charge of -1. So once again, we're going to use the crisscross method in order to figure out how many magnesiums and how many hydroxides are going to be found in this chemical compound. So we're going to bring our 1 to our magnesium, and we're going to bring our 2. I'm going to do that one. And our 2 here over to our hydroxide. So our chemical formula here for magnesium hydroxide would be Mg1, so a single Mg, single magnesium because of the charge here, and then OH. So we need to put OH here, and we're going to need 2 OHs. And how we show that is we put parentheses around our OH, and we put a 2. That represents the fact that we have 2 OHs here. Now, you may be tempted to put OH2. That would be incorrect. This is not correct. Because what you're writing here is that you have 1 oxygen and 2 hydrogens. And what we want to say is that there are 2 oxygens and 2 hydrogens. So you put a parentheses around it, and you put the 2 outside the parentheses, telling you that there are 2 of these compounds. So this is magnesium hydroxide. So Mg1, we just don't write the 1, parentheses OH, and parentheses 2. So that is magnesium hydroxide. So let's go to our final and last example here of the crisscross method. So lithium carbonate. So looking at our chart here, lithium is right here, Li with a positive 1 charge. So Li with a positive 1 charge, and carbonate. So carbonate here, I'm going to move my face. Carbonate is CO3 and has a 2 minus charge. So let us write that in. So this is CO3, which has a minus 2 charge. So that is our ionic charge. Of course, we're going to use the crisscross rule here. So this 1 moves over to the carbonate, and this 2 moves over to the lithium. So our chemical formula here would be Li2 and CO3, because we only have a single carbonate molecule, and we need 2 lithium lithiums in order to make this a happy neutral ionic compound. So that is how we use crisscross rule. It's just a very simple, our number on one side becomes the coefficient for the other. The number on one side becomes the coefficient of the other. So you're going to continue to use this in order to predict different carbonate molecules. I hope this video is useful, and let me know if you have any questions.